So we continue with the discussion on the normal and standard distribution. Now, as with the discrete probability distribution, we always want to get the probability. Like, what is a probability that x is equal to, say, 2? What is a probability when x is equal to 6? So it's the same with continuous probability distribution. But to understand or to get the probability for a continuous distribution, we have to consider the area. Okay? So for a continuous probability distribution, in this case the normal distribution, whenever we want to get a probability, we have to consider or we have to find the area bounded by the graph from the left to a certain point or to a certain value z. Okay, so again, if you want to find a probability, all we have to do is to find the area bounded by the graph from the left, from negative infinity up to the z value or the z-score. So let me illustrate this idea. Suppose you want to find the probability with, or the probability of an x value with a z-score or z value of 1.29. Okay, so the area, so that means if we are going to create a normal distribution, a standard normal distribution rather, we now know that the mean has been translated to 0. Take note, from normal to standard normal, the values in the normal will be changed to 0, 1, 2, and 3, and all the numbers in between, and then 0 to the left, which are negative 1, negative 2, negative 3, and all the numbers in between. So where is z equals 1.29 in the normal curve? So if the 0 is at the center, then that means the positive numbers are on the right and the negative numbers are on the left. So 1.29 should be located on the right. So if this is 1 and this is 2, then 1.29 is somewhere here. So let's assume that the location of 1.29 is a point closer to 1 than to 2. Okay, so find the area to the left of z equals 1.29. So what we will do, we trace an imaginary line, passing through 1.29. Okay, so that line will close the area, and then it says it to the left, and this is the area that we want to calculate. So how do we find the value of that area? To find the value of that area, we will be using a special table, which is what we call the z-table. The z-tables has two parts. The one on the left, that means from negative 3.4 up to 0, and the one on the right from 0 up to 3.4. Take note that 0 is acting as the mean. So if we consider a number bigger than 0, then this table is the one that we have to use. If we are considering z numbers that are less than 0 or negative values, then we have to make use of this version of the table. Now, a very important skill is knowing how to read the z-table. So let me introduce the parts of this table. The numbers on the first column will be the z-score with its first decimal point. The number on the first row will locate the second decimal point. For example, if the z value is equal to negative 1.3 1.34, then we have to break this number into negative 1.3 and 0.04. Take note, negative 1.3 plus 0.04 is negative 1.34, or meaning to say the values, okay, not the negative 1.3 and the 0.04. So 1.3 and 0.04 together will make negative 1.34 or 1.34. Okay, so the numbers that you can see here are all the probabilities that you can consider depending on the z-score or the z-value. So if the z is negative 1.34, again, the first thing that we have to do is to use this version because it covers the negative z-scores. So first is you locate 1.3 on the first column, and negative 1.3 is located here. Okay, now the 0.04 of the 1.34 will be located or should be taken from the first row. So again, 1.34 is 1.3 and 0.04, so that's 1.3 and 0.04. Then trace down, or you can also trace to the right and find where the two lines will intersect, and that will be 0.0901. So what does that mean? 0.0901 is the probability, or is the area, because we are still talking about the area, is the area to the left of z equals negative 1.34. So going back to our main question, what is the area to the left of z equals 1.29? So this is our main concern. What is the area to the left of 1.29? So to apply that, we have to locate 1.29. And again, to do that, you have to break 1.29 into 1.2 and 0.09. That is 1.29. So 1.2 is here, 0.09 is here. You trace until you reach the column for 0.09. You can do that in the other direction. So the value that we have is 0.9015, and that is the area to the left of 1.29. It is 0.9015. Later on, we will be translating this area into probabilities. Okay, but for now, I am still teaching you how to make use of the table. So for the first example, I asked you to find the area to the left. So what if I ask you to find the area to the right of a certain value z equals negative 1.73? So how to find the area to the right will make use of the idea of how to find the area to the left. Okay, so to illustrate, okay, take note, what we want to use is z equals negative 1.73. So if z is equal to negative 1.73, that means if you take this number, you have to break it into 1.7 and 0.03. Again, these two numbers creates negative or positive rather, because you were just breaking the numbers. So 1.7 and 0.03 is 1.73. Okay, and because this is a negative number, the table that we have to use is the table that contains all the negative z value. Okay, so for negative 1.73, first to locate is negative 1.7 and then 0.03. You trace until you reach the column for 0.03, and that is 0.0418. Okay? So the area through this value, well, to the left of negative 1.73 is like positive 0.0418. Okay, again, let us review if that number is correct. 0.0418. Okay, but remember, what we want is the area to the right. So if we are considering the normal curve, and this is 0, and negative 1.73 is here, the 0.0418 is the area to the left. So how do we find the area to the right? Now the area to the right can be obtained by using the concept that the total probability under the curve is 1. So if this area is 0.0418 and the total area is 1, then to get the area to the right, we just have to subtract 0.0418 from 1. And if we do that, we will get the area equal to 0.9582. So this is 0.9582. This area later on again will be translated into a probability, and the probability is 0.9582, or in percent it's 95.82%. Okay, so again, so far we already have an example on how to find the area to the left of a z number or z-score or z-value, and also an example on how to find the area on the right of a z-score. Now let's go back to the third question and to see what about if we are asked to find the area between two z-scores. There are at least two ways to find the area between two z-scores. I'm going to show two ways on how to do that. Okay, so let's create another bell-shaped graph. So take note, we already have the graph of a standard normal distribution and not just a normal distribution. So for a standard normal distribution, the mean now is at 0. Okay, the numbers concerned, we have negative 1.50 and 2.68. Negative 1.50 is on the left of 0. If this is negative 1 and this is negative 2, then negative 1.50 is somewhere here. 2.68, the other number, for 2.68, we can locate that number. So if this is 1 and this is 2 and this is 3, 2.68 is located somewhere here. So let this be our 2.68. Now the area that we want to find is the area bounded by these two numbers and the graph. So that's from negative 1.50 and until 2.68. The graph that we want to find, or the area rather, that we want to find is the part of the area under the graph and between negative 1.50 and 2.68. Okay, one way to find the area in between is by doing or finding it in this way. Take into consideration 2.68. The first thing that you can do is get the whole area. And to get this area, that means you have to find the area to the left of 2.68. And then after that, you find the area, this small part here, and this area is the area to the left of negative 1.5. Once you have this small portion, you have to remove it from the area you obtained through 2.68. So if you will be removing this, then that means you're subtracting the value of the area that you can find here from the area obtained through 2.68. So basically, if you want a simple way to understand this, the first thing that you have to do is to get the area, the larger area, and then get the smaller area, subtract the two, then you will get the area in between. Okay? So let's perform that. Again, the first thing that we have to use is z equals 2.68. Now we have to refer to the table in which we can find the area corresponding to 2.68. So 2.68 has to be taken as 2.6 and 0.08. So we have to locate 2.6 on the first column, and 2.6 is here. And then the next number that we have to consider is 0.08. Find where the two values will take you by considering the intersection, and as you can see, it's 0.9963. That is the area to the left of 2.68. So if this is 2.68, this area is 0.9963. Okay, as we can see from the table. Now the next one to get is the area to the left of 1.50, or negative 1.50. Negative 1.50 should be taken as 1.5 and 0.00. So going back to the table, make sure that you're using the negative values, or the table for negative values. So first, we have to locate negative 1.5. Negative 1.5 is here, and then 0, 0 is in the first column. So the first number that we have to consider is this number. We have, so the area here is 0.0668. Okay, and finally, take this area 0.9963 and then subtract the smaller area 0.6 or 0.0668, and this will be equal to, this is 0.9295. You can use your calculator to compute for the value. So the area is 0.92 or 9295, or in percent, the probability is 92.95%. Then the second approach that I was talking about is best to apply when the values, or the z values, are located and they're the same distance from the mean. So for example, if this is negative 1.50 and instead of 2.68 this is 1.50, then the best way to do, or to find the area in between, is first find this area and take note that this area is the same as this area. So let's call this area A. So to find the area in between the two curves, in between the two shaded regions, then just multiply this by 2 to get the second area, or to include the second area rather, and that is 2a. So this is a, this is also a. Again, why are they the same? Because they have the same distance from the mean. So technically, these two areas are the same. This is a and this is a. So a and a will be 2a. And then again, the total area under the curve is equal to 1. If you want to find the remaining area, all you have to do is to subtract the 2a, which is twice the area of the region found here on the left. Okay, so again, the second way is best to use when the z-scores are same distance from the mean. Okay. To summarize what we have covered here, so we tried to answer question on finding the area given the z-scores. In the next video, I'm going to show you how to find the area if we start with an x value or x values instead of a z. Also, take note that we have an example on finding the area to the left of a z-score, an area to the right of a z-score, and area between two z-scores. Later on, you will see that these questions will be the same questions that will be asked even if we change z to x or vice versa.